We're talking about 7.6. This is solving exponential and logarithmic equations. Okay? So this is going to take what we did on Tuesday, which was already pretty easy, and use it just a little bit in a few spots, but mostly to combine a few things. But solving is really not that bad. Okay? It's solving for x with like one or two little tricks added to it. Okay? So exponential and logarithmic equations, you already know what those are, so I'm not going to go over the vocab for that. You already should. One way that we can take care of an exponent is we have this little property that we can use, and it's, think of it this way, if 3 to the x equals 3 to the 5th, then x equals, what do you think x equals in this case? Anyone want to guess?
0, 2, 5.
1.
5.
5.
There we go.
If 3 to the x equals 3 to the 5th, well then x must equal 5. If worst case scenario, you think of it, those 3's cancel out, and you're left with the x equals 5 left behind. Okay? Because I had the exact same base on both sides. Alright? So that's one property we're going to exploit today. So letter A. First things first, letter A. Do both of those have the same base right now?
No.
No. But I can bring them to the same base. Like 100 is 10 squared. Okay? And my new exponent, I'm simply going to multiply by the old exponent. Okay? I'm going to bring down the old exponent and multiply it together. Okay? Now, the 1 over 10, that's not, I want to bring that 10 up into the numerator. What in an exponent says I'm on the wrong side?
Negative.
A negative. So to bring that 10 up into the numerator, I got to make its exponent negative. All right? Because 1/10 is the same as 10 to the negative 1. And then I'm just going to multiply that by the old exponent. Cool? Anybody struggling with anything that we've done up there at all?
Oh, no.
All right, from here it's easy. I got 10 on both sides. I go, you got to make the sound effects. So that's 2x equals negative x plus 3. Okay? And then solve. What do you do to solve from here?
Add it.
Add x. So if I add x to the left, it becomes a... Throw 3x equals 3. Then what? Divide by 3. So x equals 1. Juan. 2. Any questions about this? Try letter B. Take a second. Try letter B.
You did not get a 1200 on your SAT.
Okay. So that 81. The 81 can go down to a 9. 9 to the what power? So you got 9. Oop, not 2. 9 squared times x. And what did I do with the 1/9? To the negative 1. Good.
X plus 3.
Sweet. So your next line should read 2x equals negative x minus 3. Add the x, that's 3x equals negative 3. X equals negative 1. Cool. This one?
Yeah.
Well, negative 1 times x is negative x. Negative 1 times 3 is negative 3. That's one. You got to distribute it all the way across.
Okay.
You can't just make the first term negative. You got to flip the signs on everything. Yeah, go. Here. All right, turn the page. Shh, turn the page. Let's go. All right, so here we go. The last one works if you have x's on several exponents. Okay, if you have several exponents with an x on it, that's the easiest way to do it. This one I only have 1. So, question. First things first. Can I multiply that 2 and the 3 together?
No. Yes.
No.
Yeah.
You can't.
Why?
Simply because of the exponent. The exponent, and they're not the same base. If they were the same base, then we could deal with the exponents, but they're different bases. So what I'm going to do, how do I get that 2 away from that 3? Divided by 2. Move it over to the 10. Good. So I got 3 to the x equals 5. Okay? From here, since I only have one number with the variable, I'm just going to popcorn it and turn it into a log. So start with your base. Base 3 of 5 equals x. So log base 3, little 3 down and low, of 5 equals x. And you're done. Letter D. Try to see next one. Maria, you okay over there? So we started off, we probably added the 3, so 2 to the x equals 10. All right, so that's log base 2 of 10 equals x. Cool. Does that make sense? Yes, ma'am.
How'd you get 5 for the C then?
How did I get, 5 for C?
Yeah.
Okay, so the one on the right, I had to get rid of this C, 3, so I added the 3 to get 10. The one on the left, I had to get rid of this 2, so I divided by 2 to get 5. Does that make sense?
Yeah.
Same idea, different, just, hello?
Okay. Tell them to bring it by Monday.
Tell them to bring it by Monday? Is this just one packet for one person?
No, it's a lot of people in there.
Okay. Is it every people for this period?
Yes.
Letter E. All right, so I pull one on here to kind of pull those dots a little bit. So here's the deal. All of these have x's, right?
Yes.
So we're going to try to get these to have the same base and cancel it out. If you just have one with an x, that's when you would try and popcorn it. But if they all have x's, we're going to pull it out. So let's bring them all down to the same base. What is the base going to be in this case?
25 is 5 squared.
25 is 5 squared. You're absolutely right. So let's start here. The first one has already got a 5, so we'll leave that alone. The second one, you're right, is a 5 squared. I got to multiply by the old one. What about the 125? 125 is 5 to the what power?
Negative.
3. Good. To bring it up, what do I got to do? Make it a negative 3, exactly. So 5 to the third is the 125. The negative brings it up to the numerator. Cool. So you just did all that in one shot. Second of all right, now we have the same base. You can cancel the 5s out now if you want, but you're better off combining these two on the left first. Okay? So, real quick question. If I'm multiplying the same base, what do I do to the exponents?
You add them.
You add them. Well, these are the same base, so what do I do to the exponents?
Add them.
You add them, exactly. See if I can erase all that. So that literally is, good, 5 to the 3x plus 27 equals 5 to the negative 6x. All right. Now what can we do? Cancel out the 5s, exactly. So we got 3x plus 27 equals negative 6x. Okay. Where are we going to go from there? Move the 3 over, so you want to add the 3, subtract the 3. So 27 equals negative 9. So x equals what? Negative 3. And that's your full problem right there. Cool. All right, so I decided to pull one that kind of pulls out all the stops, okay? We had to combine things, we had to get everything in the same base, we had to do several things in that. But it's about as hard as these get, okay? How are we doing this? Give me 5 to 1. 5, I got this. 4, I'm okay. 3, and 2, I'm lost. All right, sweet. Slide down. Word problem. Word problems for these things, again, we're not going to make you build these. All right, what we're probably going to do, it's a lot like a science class. We'll give you an equation, we'll give you numbers to plug in, and you just plug them in and solve for what's missing. Okay? So an important application of exponential equations is Newton's third law of cooling. This law states that a cooling substance will, with an initial temperature of T of O, the temperature T after T minutes can be modeled by blah, where T of R is the surrounding temperature. So here's what everything means. Okay? T of O, well, that's your original. T of R, well, that's the room temperature, your ambient temperature. Okay? Big T is your final temp. What does little t stand for? What do you think?
What does it say over there?
Time.
TR and then...
That's your room temperature. the room temp. This is time. And last but not least, your little r is your cooling rate. Okay? So that's what all those variables are. You just got to stick in what you know and solve. All right? So here we go. You're cooking a leche, which anybody actually know what a leche is?
No. A leche is a fruit in my country.
Is it really? Well, that's a leche, not a leche, one word.
Not like leche.
Yeah, I know. It's an Ethiopian stew. Never heard of it. No, you're thinking of a leche. Not as in a singular one. All right, but here we go. But this is different. This is okay. So here we go. When you take off the stove, its temperature is 212 degrees Fahrenheit. The room is 70 degrees. And the cooling rate of the stew is 0.046. How long will it take to cool the stew to a serving temperature of 100 degrees? Because nobody wants to eat boiling stew. So here we go. Let's start sticking things down. Your T of O, what's your original temperature?
212.
212. Your TR, what's your room temp? 70. Your big T, your final temp, what do you want it to be?
100.
100, that's what they say. Your little r, your rate of cooling in this case is what? 0.046. And your little t, do we know the time? No. That's what we're solving for. Okay? So they give you all the information. The reason why I put this on here is because it's in your homework. You might as well just do it. So here we go. Start plugging them in. We got a big T, well that's 100, equals T of O, that's 212, minus T of R, we said that was 70, to the power of, and I got to write really small here, oh, it's E, to the negative 0.046 T plus 70. All right? So I just plugged everything in. Thank you, sir. Cool. All right. Let's solve. There are two things I can do right off the bat to solve this. What are they? Okay, we can do the parentheses. What's 212 minus 70? What's up? 142. E to the negative 0.046 t. All right, what else can I do? I can subtract the 70 to the other side. So what's 100 minus 70?
30.
30. Okay. All right, what else could I do? What would you do next? Take care of the 142. How do you take care of the 142? Divide. Somebody take out a calculator. What's 30 divided by 142? Or reduce it at least. This is by 2. That's what, 15 over 71?
It is 0.
Go ahead. What do you got?
0.21.
0.21? Good enough. E to the negative 0.046 t. Cool? All right. Now we're down to this. So once we got down to the base with an exponent, how did we get into that exponent? Yeah, you popcorn it. So what's your base in this case? E of 0.21 equals all of that. So ln of 0.21 equals negative 0.046 t. And then there's one more thing to do. What is it? Divide by that. So your final answer, t equals the natural log of 0.21 divided by negative 0.046, which if you want to leave it like that, that's fine. If you want to stick it in the calculator and actually get an answer, that's fine too. I don't really care which. For a word problem, I really don't care, unless they say leave it as an exact answer. Okay? I think it's something like I don't know, 80 minutes or something like that, or something along those lines. But really, it's the same thing as we did earlier, except you just plug everything in. You whittle down what you know, like you know how to combine terms. You know how to move that 7 on. You know how to do all that. This is the only new part. Base, argument, back to the exponent. Okay?
I want to know what.
You want to know what it is? I kind of do too, I haven't done it today. But anyways, turn the page. Let's keep rolling. Property of equality for logarithmic equations. Okay, so here's the deal. Remember, logarithms are exponents. Logarithms are exponents. Therefore, a lot of the properties that happen with exponents also happen with logs. Okay? For example, the one we did earlier, like if the log of x equals the log of 5, then x must equal, what do you think x would equal in this case? Anybody want to guess?
1.
5. The log of x equals the log of 5. We have the same base right here, so we can cancel those out, and we're left with an x equals 5. Cool. So that canceling out of the bases works with both the exponentials and the logarithms. Okay? They're essentially two sides of the same coin. So letter A. Do we have the same log on both sides?
No.
No. Is there some other random term being added out there in a length like that? No. So let's just cancel them out. 4x minus 7 equals x plus 5. And solve. All right, which way do you want the x's to go? You want the x's to go to the left, or do you want the x's to go to the right?
Go right.
Somebody was pointing to the left. I want to go to the left too. So x goes left, number goes right. 4 minus 1 is 3, 7 plus 5 is 12. So x equals 4. You'd have gotten the same answer if you'd gone to the right. You would have just gotten, what, negative 12 equals negative 3.
It's minus.
And you would have still got...
Minus x.
Yeah, I just moved the x to the left and moved the negative 7 to the right. Cool? Try letter B.
So you're gonna be plus.
Yeah, you're going to add the 7. Try letter B. Start recording again. There we go. Log of 6, log of 6. We got 5x plus 2 equals x plus 10. I'm going to move the x's to the left again. So that's 4x equals 8, x equals 2. Like I said, it doesn't matter which way you go. You can move the x's to the right instead of the left, and you still would have gotten positive 2 as your answer. Cool? All right, so here's the deal. This only works if everything has a log. Okay? If one thing is missing a log, you can't do this. All right? Like in the next page. Does everything in letter C have a log? No, the 3 does not. So to solve this, we're going to have to turn it back into an exponential at the popcorn. All right, so what is your base for letter C? 2. So 2 to the exponent equals the argument. So 2 cubed equals 5x minus 17. Cool? And now it is a two-step equation. What are you going to do? Okay, so 2 cubed is 8. What's 8 plus 17? 25. So x equals what? 5. Done. Try letter D. That's it. That's all it was. No. I told you today is not bad. It really isn't. Now, if you don't practice between now and the test will be bad. But it ain't going to be that bad. It ain't going to be that hard.
What is 2 to the 5?
Ooh.
25.
Don't know what 2 to the 5th is.
Nope.
125.
2 times 2 is?
4.
Times 2 is? 8 times 2 is? 16. Oh, I'm sorry. 8 times 2 is 16. 16 times 2 is? 32. 2 to the 5th is 32.
Oh, wait. No. No, it's not.
2 to the 5th is 32.
No, I was saying, never mind.
Okay.
I had to subtract this.
Okay, it's 32. Where did they come from? Did you add 6 plus? Okay.
That's where it came from. You gotta add the 6 over. Cool. So how are we doing with this one? Give me a 5 and 1. 5, I got this formal K3 and 2 of them lost. 1 saved.
1.
Sweet. Oh, you're doing better than that. All right. Ooh, I gotta charge my tablet. About dead. Letter E. Can I go ahead and popcorn that one, or is there something I gotta do to it? Yeah, I gotta take care of that 4. Can I merge it with the log?
Yes.
No. There are ways to break into a log, but that ain't how you do it. All right? So I gotta do what? Subtract the 4, exactly. So log base 2 of 5x minus 17 equals 3. Which, if you look at this problem up there, is identical at that point. So the answer to that one is 5. All right, we're not going to solve that one again. But do letter F. See if you can do letter F. Same idea. Oh my gosh.
You gotta take care of the fraction, right?
Yeah, you got to take care of the fraction.
25.
Don't yell at Hal, just do it. All right, so here we go. So to get rid of the 1/4, we're going to multiply by 4. So that's log base 3 of 10x minus 9 equals 4. Okay, to popcorn out of it, what's your base? 3. So 3 to the 4 equals all that. 3 to the 4 equals 10x minus 9. 3 to the 4th is...
A number.
81. That's okay. I don't expect you to remember that. What's 81 plus 9? 90.
Yeah.
So x equals
Shut up. Don't look at me like that.
9.
9. Cool. No, I don't expect you to memorize 3 to the 4th. Although we've done it enough, you might have it memorized, but I'm not demanding that. Cool.
That's 81.
Yeah, 3 to the 4th is 81. Plus 9 is 90. Cool. All right. Letter G.
What?
Question. We can do one of 2 things. Well, actually, we can only do one of them. But which one are we going to do? Are we going to combine the logs and popcorn our way out of this? Or are we going to get that 2 to have a log and cancel them all out?
The second one.
The second.
That's what everybody thinks.
The first one.
We cannot give this 2 a log. We can't, yeah, because it's outside of the log. It's nothing I can do. I mean, I can give it a log, but that means I got to give the other ones another log. Like a log of a log, that sort of thing. And it just gets really strange. So what I have to do is I have to combine these 2. Okay? If I have 2 logs that are adding, go back to Tuesday, what do I do to their arguments? If I have 2 laws that are adding, what do I do to their arguments? Do I add them, subtract them, multiply them, or divide them? You multiply. Remember, if it's you're adding, you multiply them, it's on top.
So it's
If
2x.
it's negative, you divide it, it's on bottom.
So 2x times x minus 5.
Yep. So we get, oop, that's a pencil. That's an eraser. I mean, log of 2x times x minus 5. They're both positive, they both go on top. Equals 2.
If one were negative,
Then if let's say this one were negative, it would be x minus 5 over 2x. Because remember, the positive ones are on top, the negative ones are on bottom. Remember that? That's how it goes. All right. Which I'm going to go ahead and clean it up a little bit because we're going to have to deal with it that way. That's log of 2x squared minus 10x equals 2. Okay. Now I can popcorn out of it. What's your base in this case? It's what?
10.
10. Good. So 10 squared equals all of that. All right, so here we go.
10 squared is 100. Yeah.
10 squared is 100. So here's the issue, though. How do I get rid of that x squared? Let's start thinking about that. I could square root it, but the problem with that is that'll take care of this one, but I'll left with a square root over there. It just enters in an equally problem. How do I get rid of an x and an x squared at the same time? Give you a hint. It's the algebra 2 F word. Nope.
No way.
Factor! That's when one goes, oh, crud. All right, so here we go. I got to get everything to one side and factor it. So we'll subtract the 100. 2x squared minus 10x minus 100. Can I do anything to reduce that?
No.
Can I divide it by anything? By 2. So that's 0 equals, 2 divided by 2 is 1. 10 divided by 2 is 5. 100 divided by 2 is 50. And now let's pull out the parentheses and go.
X on the left.
X on the left, good. What am I going to put on the right?
10 and 5.
Or 5 and 10, either one. What are their signs?
Negative and positive.
Okay, which one's negative?
10.
The 10, good. Positive 5, negative 10. So if those are your factors, your answers are x equals what?
X equals x minus 5.
Negative 5 and positive 10. Cool. So factoring is still in this. It's not going away. It has become a secondary skill at this point. Something we just know you know how to do. All right? Now, I will say one more thing. Whenever you're done with an x squared, you're going to get 2 answers, right? Every so often, though, one of them doesn't work. You do have to plug it in. Now, you don't have to solve it the whole way. All right? But let me ask you this. If I plug in a negative 5 right here, what's negative 5 minus 5? Negative 10. You can never have a negative argument. You can never have a negative argument. Period. So the negative 5 is gone. So x equals 10. Cool? That's as hard as it gets today. Turn the page. These ones are simple. They really are. Turn the page. These are simple. Inequalities. Inequalities, we're going to exploit a rule that you haven't seen in a while, but you may recognize. Remember I have something like this, 3 to the log base 3 of x. You remember seeing something weird like that at one point?
No.
Briefly? But since they're the same base, they cancel out, and I'm left with the x.
No.
Okay. We've talked about it, I promise you. We've seen it, it's just been a while. We're going to actually start using it. Same idea if we flip it. If I've got log base 3 of 3 to the power of x, again, your bases cancel out, and you're left with the x. That is a rule we are going to exploit. All right? So, here we go. Letter A. I have a base of 3. So what I'm going to do is I'm going to make both of these a log base 3 for both of those. So here we go. We're going to go log base 3 of 3 to the x is less than log base 3 of 20. Cool. Since I did it to the one on the left, I have to do it to every other term I've got. All right. Now, these have the same base, so x is less than log base 3 of 20. And you're done. Do letter B. I told you they were easy.
So the base is going to be the one that's first.
Wait, what do you do? Can you explain that again?
Basically what I did.
Oh, my bad.
Basically, since this has a base of 3, I basically pulled both of these up with a log of that base so that I could cancel that out. That was the reasoning for what I did.
Oh.
That one was
All right? So letter B, I'm going to make both of those a log base what?
3. 2.
2. Yes, ma'am. Yeah, it's right there. So that's log base 2 of 2 to the x greater than less log base 2 of 36. Those go away. X is greater than log base 2 of 36. It is easy. Straight up, it really is. All right?
Easy peasy.
Easy peasy chicken grease. Let somebody come back. Letter C.
D.
C and D. They're the same idea, but we're going to go the other way. This one has a log. What's the log? What's the base of letter C?
X. 10.
10. 10 is the base. It's not written, so it's either a 10 or an E. This case is 10. The LNs have an E. There you go. So what we're going to do is we're going to make both of them 10 to these exponents. To the log base x less than or equal to 10 squared. Cool. And the reason behind it is now these are both base 10. They cancel out. So x is less than or equal to 100. Because I can do 10 squared. Let's go ahead and do it. The logs, leave as logs. But normal exponents, just multiply them out and be done. Do letter D. Take all of 20 seconds and do letter D. I have faith. I think you can do it. You too. All right, what's the base for letter D? E. Good. So I'm going to do E to the ln of x is less than E to the 4. Those cancel out, and you get x is less than E to the 4th. Cool?
Bless you. Kind of blacked out a little bit.
Sweet? All right, we're going to do one more, and we're going to call it, okay? Let's go down to letter H. Because it highlights something that we need to be worried about. So first things first, I got that log, and it's a base E. So can I go ahead and do both sides with a base of E?
No.
I wouldn't suggest that, exactly. What do I need to do first?
Bless you.
Bless you.
You can
Well, like,
the 1.
-2 minus -1.
Yeah, let's get rid of the -2 and the -1. Like, picture this like a single variable. If that were just a big X, how would you get rid of the -2 and the -1?
Divided out.
Add what?
You add 1.
Good, so we'll add the 1. So that's -2 ln of x is less than or equal to what?
6.
No.
Fuck. 8.
8.
Oh.
All right. Now what are you going to do?
Why don't you just like add 8? Add 2?
Well, is the 2 adding to the ln or the 2 subtract? We got to divide by the -2. The 2 is multiplying the natural log. Now, this is why I wanted to highlight this one more than anything. What do I need to do at this point? It has to do with that guy right there. Why do you flip the sign? Because you're dividing by a negative. Exactly. Do not forget that rule. Now the log is alone. So what am I going to do?
You're going to do what you did the last time.
Just what we did last time. Make it a base of E. So E to the ln of x is greater than or equal to E to the -4. E to the -4. Cool? And that's about as hard as these gets on this side. I told you it was easy. I'm not going to lie to you on that.
And E, F, and G.
They're more of the same. They really are. E. Oh, E. Okay, so I got that to that. So am I going to put these to a log or am I going to put them to an exponent?
Ln.
A log. Yes, sir. So ln of e to the x, ln of 2, x is less than 2. They're all like this. It's just one similar example to the other. All right?